Hello students, today we shall study about properties of determinants. Let's start with the first property. The value of the determinant remains unchanged if its rows and columns are interchanged. Second property, if any two rows or columns of a determinant are interchanged, then sign of determinant changes. Let us solve an example to verify first property for determinants. Let us take one determinant 2, minus 3, 5, 6, 0, 4, 1, 5, minus 7. For the solution, expanding the determinant along the first row, we have determinant is equal to 2 multiplied by determinant 0, 4, 5, minus 7 minus of 3 multiplied by determinant 6, 4, 1, minus 7 plus 5 into determinant 6, 0, 1, 5. On solving, we have 2 into 0 minus 20 plus 3 into minus 42 minus 4 plus 5 into 30 minus 0. This gives minus 40 minus 138 plus 150. This on simplification gives minus 28. Now, by interchanging rows and columns, we get determinant 1 as 2, 6, 1, minus 3, 0, 5, 5, 4, minus 7. Now, let us expand along the first column. We get 2 into determinant 0, 5, 4, minus 7, minus of minus 3 into 6, 1, 4, minus 7 plus 5 into determinant 6, 1, 0, 5. On simplifying, we get 2 into 0 minus 20 plus 3 into minus 42 minus 4 plus 5 into 30 minus 0. This gives 2 into minus 20 as minus 40 minus 138 plus 150, that is minus 28. So, clearly we have seen that the previous determinant is equal to determinant 1. Hence, first property is verified, which says on interchanging rows and columns, the value of determinant remains unchanged. Now, students, let us solve another question to verify the second property of determinants. Let us take one determinant 2, minus 3, 5, 6, 0, 4, 1, 5, minus 7. For the solution, the value of the determinant on expanding it along first row is minus 28. We have done it in the last example. Now, interchanging rows R2 and R3, we have determinant 1 is equal to 2 minus 3, 5, 1, 5, minus 7, 6, 0, 4. We have interchanged second row and third row here. Now, expanding the determinant delta 1 along first row, we have determinant 1 is equal to 2 into determinant 5 minus 7, 0, 4 minus of minus 3 into determinant 1 minus 7, 6, 4 plus 5 into determinant 1, 5, 6, 0. On solving, we have 2 into 20 minus 0 plus 3 into 4 plus 42 plus 5 into 0 minus 30. On calculations, we get 40 plus 138 minus 150 is equal to 28. Clearly, determinant 1 is equal to negative of the previous determinant. Hence, property 2 is verified. Now, students, look at the third property. If any two rows or columns of a determinant are identical, that is, all corresponding elements are same, then value of determinant is 0. Property 4 says, if each element of a row or a column of a determinant is multiplied by a constant k, then its value gets multiplied by k. Now, students, look at the screen. We will be using properties 3 and 4 for solving a determinant. Evaluate 102, 18, 36, 1, 3, 4, 17, 3, 6. For the solution, note that determinant 102, 18, 36, 1, 3, 4, 17, 3, 6 could be expressed as determinant 6 into 17, 6 into 3, 6 into 6 as the first row, 1, 3, 4 as the second row, 17, 3, 6 as the third row. Can you find something interesting here? Yes, 6 is common in the first row. So, we can take it out and we can write as 6 multiplied by determinant 17, 3, 6, 1, 3, 4, 17, 3, 6. This gives me 0 as the answer. Can you tell me why? Because here property says, if we have two identical rows or columns, the value of the determinant is always 0. Here we have 17, 3, 6 as the first row, 17, 3, 6 as the third row. They are identical. So, the value of determinant is 0 and hence answer is 0. Now, students, look into the fifth property. What does it say? If some or all elements of a row or column of a determinant are expressed as sum of 2 or more terms, then the determinant can be expressed as sum of 2 or more determinants. So, students, now let us solve another example to verify property number 5. Determinant a, b, c, a plus 2x, b plus 2y, c plus 2z, x, y, z as third row is equal to 0. For the solution, we have a, b, c, a plus 2x, b plus 2y, c plus 2z and x, y, z determinant can be expressed as sum of two determinants, namely determinant a, b, c, x, y, z plus determinant a, b, c, 2x, 2y, 2z, x, y, z. I hope you have followed this step. We have separately written this in the form of two determinants. Now, by using property 5, the value of each determinant above is 0. So, 0 plus 0 gives us 0. Now, let us look into the property number 6. If to each element of any row or column of a determinant, the equimultiples of corresponding elements of other row or column are added, then value of determinant remains the same. That is, the value of determinant remains same if we apply the operation R I is given by R I plus k into R j or C I obtained by C I plus k into C j. Now, students, let us learn how to calculate area of a triangle using expansion of determinants. Area of a triangle with vertices x1 y1, x2 y2 and x3 y3 is given by determinant is equal to half of determinant x1 y1 1, x2 y2 1, x3 y3 1. Note that since area is a positive quantity, therefore, we take absolute value of determinant. Now, students, let us solve a problem using the above formula. Find the area of the triangle whose vertices are 3, 8, minus 4, 2 and 5, 1. For the solution, as we know, the area of the triangle is given by the formula determinant is equal to half of determinant 3, 8, 1, minus 4, 2, 1, 5, 1, 1 can be simplified as half of 3 into 2 minus 1 minus 8 into minus 4 minus 5 plus 1 into minus 4 minus 10. This again can be written as half of 3 plus 72 minus 14, that is equal to 61 upon 2 square units. Now, let us solve another interesting problem. Find the equation of the line joining points A 1, 3 and point B 0, 0 using determinants and find K if D K 0 is a point such that area of triangle ABD is 3 square units. For the solution, let P x y be any point on AB, then area of triangle is 0, because if the points are collinear, the area has to be 0. Therefore, half of determinant 0, 0, 1, 1, 3, 1, x, y, 1 is equal to 0. This gives half of y minus 3x is equal to 0 or y is equal to 3x, which is the equation of line AB. Also, since the area of the triangle ABD is given to us as 3 square units, we have half of 1, 3, 1, 0, 0, 1, k 0, 1 is equal to plus or minus 3, which gives minus 3 k upon 2 is equal to plus or minus 3, that is k is equal to minus plus 2. Here, students, there are some interesting and important remarks for you. First, since area is a positive quantity, we always take the absolute value of the determinant. Second, if area is given, use both positive and negative values of the determinant for the calculations. Third, the area of the triangle formed by 3 collinear points is always 0. So, students, today we studied about the properties of determinants, their verification, area of triangle using expansion of determinants. In the next session, we shall study about cofactors and minors of determinant, inverse and adjoint of matrix. Thank you.